in some GATE exam in some of the year. So the question is, if you treat this ketone, in one side there is a tertiary butyl group and another side ethyl group with LDA tetrahydrocurate at minus 70 degrees centigrade in presence of benzaldehyde, the product, what will be the product? So this is one question, and another question is, there is a cyclopentanol in presence of the same reagent. This gives the product Q. So what will be the P and Q? That is the question. So as you know that LDA, lithium diisopropylamine, this is a strong base. So in presence of a ketone, it will abstract one alpha hydrogen from this ethyl group. There is no alpha hydrogen in tertiary butyl in this tertiary butyl group. So one alpha hydrogen will be abstracted and the corresponding enolate will be formed. So in this case, there is a probability of formation of two enolate, in which one will be cis, in which the CH3 group will be cis in one enolate, and this CH3 and the O will be on the same side, and in another the CH3 and the O will be on the opposite side. So in the same side it is called cis enolate, this is cis, and this is called trans enolate. So this now in trans enolate, as you can see, there is a tertiary butyl group which is a very bulky group. So the two group will be on the same side, so there will be some steric crowding here. So that is the reason this unit will be produced in minor amount and the cis unit will be produced at the major amount. Now when this cis enolate will react with benzaldehyde, so what will happen? A cross aldol reaction will take place. That is, the product will be this. Now our question is, what will be the stereochemistry of this CH3 and OH group? So this we will discuss and just before that, before going there, we'll also see in the second reaction. It is of similar type. So in the cyclopentanol, one of the alpha hydrogen will be abstracted by the base, the corresponding enolate will be formed, and then it will attack to benzaldehyde. So this is similar aldol type reaction, cross aldol reaction. So here also the question is, what will be the stereochemistry of this carbon and this carbon? So OH and this bond, what will be the disposition of this two? Now to explain this, this can be explained through the Zimmerman traxler transition state. So we'll come to there. So for the first reaction, this is the Zimmerman traxler transition state. So this is the disposition. Here you can see this is the enolate, here the CH3 group and the O group, and there is a ketone, there is a O group which is in the similar side. So this is the cis enolate only. Now the benzaldehyde which comes, this transition state is actually a chair-like conformation of cyclohexane. You can see here that it is like this only. So this is the chair-like transition state, in which the pH group, which is the bulky group of the aldehyde, which come in a pseudo equatorial position. This is the stable structure, because if the pH goes in the pseudo-axial position, then there will be steric crowding between the tertiary butyl group and the pH group. So this is most stable transition state. So from this transition state, what will happen? So this bond will be separated here, and from this carbon it will attack into that carbon and it will convert it to a alcohol group. So it will convert it to this. Now, if you can look between these two bonds, the bond which will be found here, if we look between in this bond, then the disposition of the other group will be like this. That hydrogen, this is the hydrogen, and it will be the alcohol group, and the pH will be this side. Similarly, the CH3 group will be here, and this bond with OH, it will be a ketone only, and then the CH3. So if you see here that the CH3 group and the OH group, those are in the Gauge position. Gauge position means if we draw this way, then this is the CH3, this is the H, O, and here it is OH, H, and CH3. Sorry, this is H. So this CH3 and OH, this is in Gauge position and in a similar side. So in this, so our question, this question, the CH3 and OH, both will be in the similar side. So the product will be H, that is in the, both will be in the above. Or you can show both will be in the below, that are similar only. Now we will come to the second one. Hope you understood this transition state and the mechanism. Now we'll come to the second reaction. Similarly, this is the enolate. This is the enolate. Here the 5-member ring. As you can see, this is the 5-member ring. This is the 5-member ring. So similarly, here the reaction will be like this. It will attack into here and it will be converted into an alcohol group. So if we draw this similar way and look into this bond, this bond will be formed. So the OH group will be come here, and this hydrogen is this hydrogen, and the pH will be this, and this hydrogen is this hydrogen, and it will be the ketone group, and here this is the part of the ring. This two carbon will be part of the ring. So you can see here that our what will be the stereochemistry of this carbon and the alcohol. So if we draw this and project, if we project this, then it will be Fisher projection. Then it will be the hydrogen will become, this is the front carbon and this is the back. This is the back carbon. So in front carbon, hydrogen will be in the below side, and this is the in right side, and sorry, this is the left side, this is the right side, and here the hydrogen in the rear carbon, the hydrogen is above, the pH is in the left, and the OH is in the right. Now you can see this carbon and the OH both are in the anti-position, staggered position. So in the product, the stereochemistry will be, if it is above, then the OH will be below. So this will be the stereochemistry. So guys, if you have any doubt, in this question, please let me know in comment box. And I will come to you with such interesting type of question. So get in touch and subscribe my channel. Thank you. Have a good day.